Hi everyone, my name is Abel Greykantoma. On this video I'm going to be showing you how to do your designs using your mobile phone. Okay, we are going to be using RCC spreadsheet. Okay, this works both on phones and even on your system. Okay, you can actually use it. Okay, your spreadsheet. Okay, this is a schematic card viewer. You can use it to view your AutoCAD drawings, okay, or any CAD drawing, okay, whether DXF, DWG, and so on and so forth. Now, if you have been following, this is the GA we have been using right from time. Okay, we have used this GA to do our design using RCD 2000. You can go down under the description box. You'll find my videos that I've done on RCD 2000, on Orion, Prota Structure, Revit Architecture, and AutoCAD. Okay, and keep yourself busy. I will still advise you to watch my videos on RCD 2000. Okay, now on this GA you can see that this drawing, there is a cycle here which I use to indicate this shape. You see it's an L shape. Here you see a T shape. Okay, that makes beam 1 an L beam. That makes beam 2 a T beam. Okay, now if that is correct, now we are going straight into our beam designs. I've done designs on slab already. It's in my YouTube channel. It's already in the description box. If you like what you're seeing, why not give it a thumbs up? Subscribe to this YouTube channel. It's actually free. Okay, just click on that red button down below this video. You will see subscribe. Just click on it. Okay, and then click on the bell icon so as to get a notification whenever I post videos. I post videos like this on weekly basis, sometimes on a daily, so as to encourage people who are trying to understand how to design. Okay, now let's go straight into our design. We are going to design our beam 1. Okay, now to design our beam 1, like we know this is an L beam, go to your RCC spreadsheet. Okay, before then, let me just quickly show you something just came to my mind. Look at this. We have 3830, that is the span, which is uniform. Okay, and then we have 3 spans. Okay, we have 3 spans and they are all uniform. And if you notice, 3830 is the maximum span. Like, there's nothing greater than that on this particular beam. Okay, now if we go to our spreadsheet, we'll specify number of spans. Okay, we have 3 different spans. We have 3 spans. Okay, click on edit. We have 3 spans. Okay, you enter. The next maximum span is 3.83. Go next. What is the depth? 450. Okay, next, what is your BW? Your breadth of web is 230. Okay, which is correct. Your HF is 150, which is the thickness of your slab. Okay, which is correct. We are using a thickness of slab of 150. Okay, our slab is 150. Okay, your BF, you can see it's showing you red. Okay, let me briefly explain something here. Now when you come slide to this place, you see that it has designed your BF for us like automatically 498. If you remember, in our RCD 2000 design, we did the calculation of this BF manually. okay, your breadth of flange. We did that calculation manually, and this is the value we got, 498. So it's actually correct. Now this RCC spreadsheet has done that calculation for us here automatically. Now look at these instructions here. It says operating instructions. Enter data in blue cells only. 3 or more spans with UDL. Okay, red messages indicate entry error. So you can see we had a red message on our BF. Okay, so we have to go back there and change it to 498. Okay, red indicates entry error. Single layer rebar only. Okay, shortest span must be 3.256 meter. Okay, now let's come here. See, now see your BF. Now let's edit it. Sorry, let's edit that BF to 498. Okay, you see it has changed to blue. That means our BF now is correct. Okay, now let's come here. Our top cover, that's your concrete cover, your bottom cover, your side cover. Okay, the shape is an L beam, so we'll leave it as L. If it's not, we change it to T. Okay, here you can see it's already giving you your bending moment diagram. Okay, it's already giving your moment diagram. Characteristic strength of concrete. Okay, characteristic strength of steel, of your mild steel. Okay, density of concrete. Okay, see the status is valid design. Okay, let's come here. Your dead. Okay, that is the equivalent load on beam. You know, from that instructions that we read earlier on, it says we only enter our blue cells. So 1.7 was generated automatically, so we don't need to touch that. Our dead load. Now we can come here. Let me briefly explain your equivalent load on your beam. Okay, that is the load is actually coming from your slab down to the beam. Okay, now your equivalent load on beam here. Now see, this is the formula for long span, for short span, for one-way slab. Okay, and then you note your K is equals to LX over LY. If you substitute it in that long span formula where you have K square. Okay, so it is LX, that is your short span, divided by your long span, you know, for your slab. Okay, your slab short span divided by your long span. Okay, you know the beam is actually carrying the slab directly. Okay, so if you go to this drawing, you see that this beam 1 is actually carrying panel 1 on the shorter span of that panel 1. It's carrying panel 3 on the shorter span. Okay, it's carrying panel 4 on the shorter span. Okay, on a particular span. Okay, now on this short span, you know, on our design it says that we should specify our maximum span, but you know all the span are actually equal. Okay, and then the dead load that is acting on them actually for your panel 1 and panel 3 are actually the same, because panel 1 and panel 3 are actually similar. Okay, panel 1 and panel 3 are actually similar. So we got 13.43. You know, we sum these plus 3.01 in when we were doing our RCD 2000 calculation, but here we are not going to use 3.01 because RCC spreadsheet has already given us our self width. Okay, so we don't need to use 3.01 in RCC spreadsheet design because it has already given us our self weight. It will generate our self weight automatically itself. Okay, now this equivalent load on beam on RCD 2000, it will generate the value for us, which is 13.43. You can see that it's acting on this particular span, and on this span too is 13.43. On this span is 9.1. Okay, so here we are going to use 13.43, but I'm going to show you how you can get it manually, whereby you don't need to follow through RCD 2000. Now, how to do it manually is from this formula. Okay, since the beam is actually carrying that panel on the shorter span. Okay, beam 1 is actually carrying panel 1, panel 3 on the short span, and then the maximum span is the load on the maximum span is actually what we are going to use to do this design. Okay, so the load on that maximum span, which is 3.8083, which is on our short span here, is carrying that panel on the short span. You can see this is the formula we are going to use. This is short span 1/3 WX. Okay, if you substitute, your W is the load from your slab, which is 10.52. If you come here, 0.15 times the density of concrete. Okay, by the time you're done with all of this calculation, using your life load of 1.5, you are going to get 10.52. Okay, I explained this in our previous video. Okay, do well to go through that YouTube channel and get that to give you a better understanding of what is actually happening here. So now, if that is correct, now we substitute this. When you do this manually, you are going to have 13.43. You can confirm this from our RCD 2000 that we did, okay, in our previous videos on RCD 2000. Okay, you can visit my YouTube channel to get that. Okay, but this is how to get it manually. Your equivalent load on beam. Okay, this is load coming from your slab to the beam. Okay, 13.43, which we got here, and that is what we are sending to this particular beam. Okay, 13.43. You can see that is the highest load. The one on this place is 9.1. Okay, so we are going to use 13.43 for our design. So 13.43. Okay, you know, we don't touch. Now the blue cells generate automatically itself. Okay, so you don't need to edit that. Now the imposed load, you can see here, is 1.5. Okay, this imposed load is not a constant value of 1.5, so it is based on what you are designing. Okay, we have different classes of design. We have residential, we have industrial, we have educational. Okay, and on each classes of your design, we have different types. Okay, and you may even have a life load of even 12.5. It depends on what you are designing. So I will still advise you to lay your hands on Simplified Reinforced Concrete Design Book by Victor Oyenuga, or you can get Mosley and Bongi. Okay, these are reinforced concrete design books, or you can get other design books. It depends on which country you are coming from. Whatever that is recommended in your country, you can lay your hands on them, and you'll be able to get all of this correctly and better. Okay, now if that is correct, our concrete cover, all we use 25, 25, 25. Okay, let's come here. I want to show you something briefly. When you come to this corner, you discover that there is no any error message or message showing that anything is inadequate. Everything here is okay. If you have if your concrete cover is not adequate enough, it will tell you by the side of the screen. Okay, you are going to see it written. Okay, so our design is actually complete. right now. You can see everything is okay. Our cover is okay, single layers are okay, our bar spacing is okay, the deflection, the shear, everything is okay. Okay, so our design is actually complete. You can see how simple it is. Okay, if you're already liking this, okay, why not just leave a comment down below? Amazing, right? Just with our phones, this is the magic we can perform with our phones, and this is actually correct. Even when you compare it with the one you do on your system, you are still going to get exactly the same result. Okay, it's actually correct. You can print this directly. Okay, you can connect this to your PC and